Hi, BC friends. I'm going to do the first homework assignment over break pretty quick here. I'm going to bounce back and forth between OneNote and Desmos, so it might be a little bit odd in terms of, you having all my work sort of accessible to you, but hopefully this will work for you guys. So the first one, right, we're trying to graph r equals -5 sine theta plus 3. You can tell that since the magnitude of A, 5, is bigger than the magnitude of B, 3, that this is, it's going to be that Lima-san with an inner loop, right? So you guys get your 4 compass directions there, and then, you can pop them into a graph, and you get something that looks like this, and that should be good, okay? That part I hope we're good with. The second part is tricky, right? Because we're trying to find the area of this inner loop. And to do that, right, we need to find out where r equals 0, right? Because those are going to establish the bounds, right? We know that we're going to have my 1/2 r squared, the integral of that, right, from this past screencast, I should say, right, from over here, right? We knew that this whole area is pi r squared, right? And so when we multiplied that out, right, we got this 1/2 r squared d theta right here, and that was sort of the powerful thing, right? That looks something like this guy down here all the time. That's what we're after, right? So to get to that, we need to know where r is 0. And to find that, right, we need to use our calculators because we don't know we don't know where r is when sine theta equals 3/5. So let's find how we would do that. Okay, so I'm going to use my graphing calculator here on Desmos, and I'm going to graph y equals sine x and y equals 3/5, right? Because this will give me my 2 bounds. So you might have been used to solving this, with an inverse function, and you probably can on Desmos. I'm sure you guys are better at that than I am, right? But here I've found that 0.644 and 2.498 should be my bounds, right? And if we plug those in here, 0.644 and 2.498, right, we see that we only get this loop, okay? So that establishes my bounds, and then I can go plug them in, right? So again, we have this 1/2 r squared d theta. So for my integral portion, right, I'm going to have my 1/2 on the outside. I'm going to have my 0.644, I think it was. I don't remember. 0.644 and 2.498 is my 2 bounds. And what is my r squared? Well, that's just what r is squared. D theta. You might ask, does it matter that r might be negative in this region? In fact, r is always negative in this region, except when it's 0 on the bounds. And the answer is no, right? Because it's squared. So we're going to get a nice positive volume or area, no matter what. Okay, so that's sort of how we do question 1 really fast. Question 2, right? I have this same setup, right, where I'm asking you to graph something without a calculator. Hopefully you were able to do that. I don't know why my pen stopped working there. Right, you did the same thing here. Maybe if you knew your stuff and you're an immature boy, you saw that A and B had the same magnitude, so you said like, oh, it's gonna be a but, and you're right. Okay, so if I plug in 0 here, I get 0 out, and then I get 4 out, and then I get 8 out, and then I get 4 out. Okay, so that looks something like this, right? And so I ask you in part B to set up an integral expression to find the area inside the graph that lies in the second quadrant, right? So we're talking about that top left quadrant. And unfortunately for you guys, I don't tell you how you end up there. And the naive answer might be to say, oh, of course it's pi over 2 to pi, right? But if r were always negative, it would actually not be, right? It would be from 3 pi over 2 to 2 pi. So we have to be a little bit careful there. It turns out this one is always non-negative, so it is actually from pi over 2 to pi. So what does that integral expression look like? Right? It looks like 1/2 times the integral from pi over 2 to pi of this thing squared. Again, if you actually wanted to find that on Desmos, I don't think I said this on the first one, right? You need to wrap the whole thing in these big parentheses, or else it's not going to like it, right? So make sure you do that on Desmos so you don't get a syntactical error. That's sort of the answer for B. And then C is going to require a little bit more algebra than I think we might otherwise want to do, right? I want to find the equation for the tangent line when theta equals 3 pi over 2, right? And so to remember to do that, right, we're going to want something that looks like this, right? X1, Y1 are the rectangular coordinates of that point down there, right? Not the polar coordinates, the rectangular coordinates. Fortunately for us, that's easy, right? That's just this guy right here. 4 in the 3 pi over 2 direction, that gives us 0, comma, -4. We have to be careful, -4 here, right? So we all know the difference between rectangular coordinates and polar coordinates, right? So rectangular coordinates are sometimes called Cartesian coordinates for the Cartesian coordinate plane. So a classic joke is that some people might say that, what's the difference between a polar bear and a Cartesian bear? Well, they might look like this. That one's great. Hopefully your Miss Yam friends have been talking about that one. They watch an old screencast of mine where I couldn't stop laughing at this great joke. Hopefully now you have to pause the video because, tears are streaming down your face at how funny this one is. Anyway, coming back to this. So we have our Cartesian coordinates or rectangular coordinates for x1 and y1, but we need to find m. Remember, m here was dy dx. And you'll say, uh-oh, we don't have any y's or x's. Well, we know that this is really dy d theta over dx d theta. And we know that y is r sine theta and x is r cosine theta. And if you're wondering why I left so much space there, it's because we're going to need it, unfortunately. So I could find dy d theta. R sine theta is really r times, or sorry, not r. It's -4 cosine theta plus 4 times sine theta. And this is really -4 cosine theta plus 4 times cosine theta. Sorry, we're a little out of practice. It's been a while since we, did a great deal of calculus. So, dy d theta then is, we're taking a derivative of this mess, which is just going to be this mess, times the derivative of the second, which is cosine theta, plus the derivative of the first, which is, what is that? That's 4 sine theta, times the second, sine theta. Well, I want to know what this is at 3 pi over 2, I guess. Right? So what is that? -4 cosine 3 pi over 2. Bleh. That sounds like 0 to me. So this whole term is 4 times 0. That goes away. And then the second piece is 4 times -1 times -1, which is +4. That's good. And then dx d theta, we have to take this derivative also. It's going to be very similar. It's the mess times the derivative of the second plus derivative of the mess times cosine theta. Okay, and dx d theta, evaluated at 3 pi over 2, is this is a 3, is equal to, let's see, cosine is 0 there, so that's just 4 times negative sine theta, negative, so that's +1, plus 0, so this is just 4, okay? So they're both 4, meaning dy dx is 4 over 4, which is 1, meaning that my equation would be y minus -4, so +4, equals 1 times x minus 0. That is the equation to my tangent line when theta equals 3 pi over 2. Okay, let's go on to this fun guy here. Oops, already started that. That's awkward. Okay, so this problem, I don't know if I said it was calc active on the screen, on Canvas. I hope I did, because it certainly is. So let's do let's talk about this guy. So I traced these two curves in two different colors to illustrate that sort of our inner bound is sometimes the blue function and sometimes the orange function. So the area, we could sort of say, is this quarter circle plus this weird piece. I don't know what that is, but they're two different pieces, right? So if we were going to start that, we would definitely want to talk about the easy one, right? The left side, which is just going to be 9 pi over 4, right? Because that's that area. It's half a quarter of the circle with radius 3, so that's just 9 pi, right? Pi r squared. So the second part is kind of scary, though, right? Because we got to think about bounds over there. We got to think about a lot of stuff. Okay. Fortunately for us, they gave us this 0 to pi business. So we know what traces this out. And if you were to plug in 0, you would get 3, right? So here we know that theta equals 0, r equals 3, which is somewhat comforting to us. So we can simply just take the integral, 1/2. My bounds are going to be from 0 to pi over 2, right, of this thing squared. Okay? Simple. Not incredibly complicated. You could punch this into Desmos. I don't know what you get. I don't really care. But this is what our friend is. I'm sure this problem is Googleable if it's a past AP. I don't know, in the last 2 decades, we'll say. I don't know where I got it from. So for the curve, this thing, find the value of dx d theta at theta equals pi over 6. Okay, well, dx d theta, just like we just did, we want to know this. Well, I know x, right? That's our cosine theta. So I know x is 3 minus 2 sine 2 theta times cosine theta, right? So what is dx d theta? Well, that's going to be a mess. It's going to be 3 minus 2 sine 2 theta times negative sine theta plus, what is this? Negative 4 cosine 2 theta times cosine theta. And now we would be plugging in pi over 6 and really testing Mr. Perlis's patience and knowledge of the unit circle, honestly, at this point. So 3 minus 2 times sine of pi over 3. That sounds like root 3 over 2. So this thing times negative sine of pi over 6, so negative 1/2. Plus negative 4 cosine 2 theta, cosine of pi over 3. Again, we're doing this at pi over 6. Cosine of pi over 3, that's just 1/2, times cosine theta, which is, where are we? Pi over 6, root 3 over 2. So it's whatever that is. I would just leave it, because why would I... I'm not trying to be a hero here. Okay, so that's what that is. Again, Googleable somewhere for sure. And then part C, the distance between the two curves. Have we talked about that? No, but you can use your minds and figure it out, right? Between these two curves changes from 0 to pi over 2. Find the rate at which the distance between the two curves is changing with respect to theta when theta equals pi over 3. So what is this distance between the curves? Well, let's look about it. Let's think about it, right? We're talking about this distance here, right? This distance between them, right? As that's a terrible angle, though. Really, it should be like this distance here, right? We're talking about in that first quadrant, right? Because they tell us from theta equals 0 to pi over 2, right? So we're talking about blue minus orange, right? We're just talking about blue minus orange. So this distance is just 3 minus this thing, right? Well, I'm sure you'll notice that those 3's are going to cancel, and we're just going to get 2 sine, this 2 theta. Did I forget a 2 there? I did. 2 sine 2 theta, right? So this distance, d, is just 2 sine 2 theta from 0 to pi over 2 or something like that, right? So all we want to know is how fast does this change with respect to theta. So d theta is just the derivative of this, right? So that's going to be 4 cosine 2 theta. And we want to know what that is at pi over 3, right? So d theta at theta equals pi over 3 is going to be equal to 4 cosine 2 pi over 3, which of course is negative a half. Right? So this whole thing is negative 2, right? So let's look at this picture and say when theta is pi over 3, right, the distance between these guys is getting smaller. Do we buy that? Yes, right? Because the orange is getting closer to the blue at that point as we move this way. So that makes some sense. Okay? A particle is moving along the curve, blah, 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 so that d theta dt equals 3 at all times t greater than 0. Find the value of dr dt. Okay. So we want to know what dr dt is, and this one might have been a little bit perplexing to some of you, right? Well, we know that dr dt, right, and this we can think about our related rates background here, right, is going to be equal to dr d theta times d theta dt. Well, this is good, right, because we know what dr d theta is, and we know d theta dt is always 3, right? So what is dr d theta? Right, dr d theta is just the derivative of r, right? And that derivative of r, have we found that already? Well, r is 3 minus 2 sine 2 theta. Oh, I guess we just did, right? And so the derivative of this is going to be what? Negative 4 cosine 2 theta? Negative 4 cosine 2 theta. Okay, and d theta dt is always 3. Right, so dr dt evaluated at theta equals pi over 6 is going to be equal to dr d theta at theta equals pi over 6 times 3, right? 3. So d theta dt is always 3. So what is dr d theta at pi over 6? Dr d theta at pi over 6, well, that's just negative 4 cosine pi over 3, which is just negative 2. Right, so this thing is negative 2 times 3, or negative 6. Okay, and that again is saying that as we move along, as we move along the orange curve at pi over 6, we're decreasing rapidly. So that should make sense. Right here, r is decreasing rapidly again as we move counterclockwise. All right, Google this one if you want to find the answers to those other guys. I think if you just literally start typing into Google the graphs of the polar curve r equals 3 and r equals 3 minus 2 sine 2 theta, you will find this problem. All right, I hope you are enjoying the last few hours of break.